let's see, there are a couple of announcements. First of all, I hadn't posted the solution for the first assignment yet, so you guys still have another chance to submit it. Of course, there will be penalty for that if you submit it late, but for those who have not submitted, you can continue now. So as long as I have not posted the solution on YouTube, yes, you're allowed to submit, but I'm going to take like a few points off, okay? That's the first announcement. The second one, let me see. We have the second test soon, right? So we have around maybe about like 10 days. Again, I really want you guys to get together, help each other, okay? Do the sample test. The sample test will help you. You guys don't do the sample test, I'm sure, 100% sure that you guys don't have enough time to go through 10 problems. And I have to say, there's some of the problem in the sample test, I'm going to put it in the real test. Okay, I don't change anything because I know that that problem will take time, so it requires you to think. So it's good if you already think that at home, you know, then you go to class and you know how to do the problem right away. Okay. Regarding for the second assignment, I have to say that as long as we finish the lecture today, you should be able to do the last two problems. Actually, I believe that you guys have enough knowledge to do the last two already. We just use basic trigonometry ratio or all the formula I provided last time. You use that to do a problem. That's, I believe it's 5 and 6, right? Yeah. Some of them require you to think. I'm sure, especially the one with the geometry shape. You have to think a little bit, okay? And the best way to crack that problem is to get together. One brain is not enough. You need to get more brain. So you need to get more brain. 2, 3 students get into one group. 4 students. Last time I had class, and the whole class considered as one group. So there are 10 students get into one group and try to crack the problem. Okay? And you guys, for those who missed the assignment, unfortunately that's very bad because this assignment accounts for 20%. Think about it. If you miss one assignment, 3% gone. 3% out of your total grade gone. So if you miss like 5 assignments, for example, how many? 15% gone. So assignment is more important than the test. Okay, because it prepares you to another level. The test is easier than the assignment. I have to say that. Okay. But oh no, this is trigonometry. Everybody has the same path here. You guys need to go to engineering, computer science. So you guys have to prepare, and this is my responsibility to prepare for you. Okay. We're not here to do just basic like sine x equal to 0, x give you something. No, that is for a little kid. We don't do that in this class.
You got the sine sheet?
Because if we do just a basic one, then when you do engineering or any other science path in USF, then it will be hard. Okay? One more thing. Today we're gonna have a pretty short lecture, hopefully. Then the rest of the time I'm gonna give problem on whiteboard, and I really recommend you guys to join me in that activity. It's not really active. I give you guys extra credit if you guys volunteer go to whiteboard and finish the problem. And we sure that one is right. I give you guys 2 points added to the first test. So that's a chance for you to make it up. For example, if you fail the test, well, hopefully you don't. Okay, but I really recommend you volunteer and do the problem. It's like last time, a couple of students here already got 2 points, so I'm very happy for that. Yeah, because when you go to the whiteboard and you do the problem, you know where you're at, and I can help you to prepare for the real one. Okay? Any other question? Any concern? How about homework? Homework is good? Homework is very standard, right? I have to say that. Kind of similar to what we learn in class. Alright. I just read the news, and this is what they say. Actually, I think it's really interesting to those who do the STEM path, do the science. They say that, I don't know if I already mentioned this, they say that the galaxy is kind of moving apart from each other. And the reason they're moving apart from each other because of dark energy. You guys know dark energy, dark matter. But right now, at this moment, they say, no, it's not because of dark energy anymore. So it's been correct for like, how many, 15 years already. And now they say, all the astrophysicists and theoretical physicists, they say, it's not because of dark energy anymore. So you see that things change over the time. Before they said theory of relativity, always correct, always true. Until they find out some particle that travel faster than the speed of light. And they said, relativity, theory of relativity is not correct anymore. At some point of the time, at some part of the universe, so things change. So we have to keep changing also, we keep getting better and better and better. The bad thing is that all the physicists and mathematicians, they keep thinking up new things for us to study. So they no boundary in physics, no boundary in mathematics. Even you guys love math and you guys get a PhD in mathematics, there's no boundary. They keep thinking more theory, more theorem for you to study. So don't worry that you don't have enough things to study. Believe me, that they still have a lot of things for you to study. Okay, I have to study too. At home, I go home, I do more math. You know, high level math. You know, I don't just stop over here. Okay, so I want you to do the same thing. Okay, you guys don't study by just coming here and do math over here. You guys go home, do more math. Okay, spend more time because. That is prepare you for the future. That's it. Okay? Any question? Alright. Good. Today we talk about one of the very important circle in mathematics. And this circle has radius 1. It has radius 1. That's why we call it a unit circle. Okay? So today we talk about a unit circle. Anyone remember the equation for the circle with radius 1 and the center as the origin? Anyone remember that equation of circle? You already learned this in college algebra. What is the equation of circle with radius 1 and center as the origin? Anyone remember?
What was the question?
What is the equation of the circle with radius equal 1 and has center as the origin?
R squared pi. No, that's the.
Okay. Yes.
It's like 2 pi r squared or something.
2 pi r squared.
R
You're
squared.
thinking about a formula to find the circumference or formula to find the area? That's not an equation. Yes.
X squared plus y squared equal 1.
X squared plus y squared equal 1. Very good. Actually equal 1 squared, but 1 squared is 1. Okay? So this is the equation of the circle with radius 1, the center as the origin. That's why we call it unit circle. So every time we talk about unit circle, we talk about a circle with radius 1, and the center is at the origin. Okay? And over the past few weeks, we learned how to display all the trigonometry ratio of special angle using the table. So I give you two tables, and special angle is 30, 60, 90, 180, 270, 360. Okay? We can display all the trigonometry value at special angle using this circle also. Okay? So go ahead, draw a circle with radius 1. Okay. And because this is a circle with radius 1, so the coordinate at this point here should be 0, 1. Okay. So the coordinate over here is 1, 0, and the coordinate here will be negative 1, 0, and down here is 0, negative 1. So I can displace all the trigonometry value at special angle on certain part of this circle. So instead of memorize the table, there's another way to memorize those values, those special angles. Okay? So I want to divide this circle into 12 parts. So let's just divide into 12. So 6 parts on the top and 6 parts at the bottom. Okay, so let's divide it. I forgot my projector. So something like this. So 3 parts on the first quadrant, 3 parts on the second quadrant. Okay, and 3 parts on the third, 3 parts on the last quadrant. All right, so I just connect them. Okay, it's not really perfect, but that's all right. There you go. So this is the center right here. 0, 0. And I divide the first quadrant into half so that we have 45 degrees. Okay, so I'm going to use let's use different color for that. So let's go through here. There you go. And this is go through here. So I divide the second quadrant and the fourth quadrant into half also. There you go. This circle is very important because on this circle, on trigonometry function found by the angle theta. In this case, this is the angle theta. For example, I pick one point on the circle and I pick this one. Okay? And this is the angle theta. I can express the trigonometry function as the function of the arc length. And this function of the arc length. So this is the arc length. Last time we already learned the arc length, you know, the formula I give you guys. S equal to theta r. Okay, so this is the arc length. And I call this arc length S. Okay. So when it's expressed as the function of the arc length, on trigonometry function, we call the circular function. Okay? So in order to get the circular function, let's start with the formula. Last time we already learned S equal to theta r. r is the radius. Well, last time I believe that I used small r, I believe so. So let's use the small r instead of the big R. Yes, let's use the small r here. Okay. And because this is the unit circle, okay, so an r equals 1, r equals 1, so s become theta, because r equals 1, theta times 1 is theta. Okay. Everybody know this symbol, right? I assume this means implied. And I don't know if you guys still remember one of the formula I provided you when we talked about, the first time we talked about trigonometry function. I said that psi of theta equal to y over r. And this is y. So if I pick this as the point I want to consider, this is y. Okay. Okay. And over here is x. From here to here is x, and from here to here is y. Okay. Sine equal to y over r, and cosine equal to cosine of theta equal to, look at the triangle here, this is right triangle. And cosine equal to, this is r because that's the radius of the circle. So cosine equal to what? X over r, right? And cosine equal to x over r. This is what we already learned, okay? This is very a regular trigonometry function or trigonometry ratio. And now I want to express that as the circular function. Okay. Right now, what we just got here is s equals theta. So I can replace theta with s. So sine of theta becomes sine of s, okay, equal to y, and radius right now is 1. So I can write sine of s equal y. And the same thing, similarly, I can write cosine of s equal x. Okay. Cosine of s equal x. And from sine of s and cosine of s, we can get the tangent. Tangent of s equal to, so with y over x, right? Tangent equal to sine over cosine. And sine equal to y, cosine equal to x, so we give you tangent of s will equal to y over x. And of course, from there I can get cotangent of s is x over y, and so on. And so I can say that all the function here in terms of x, y, and arc length s. Okay, this becomes circular function. Okay, circular function. Okay. So right now the value on the circle and on the special angle on the circle, I can display it on at each point here. I can display it on the circle instead of using the table. So if I divide the circle into 12 parts, so on the top we have 6 parts, at the bottom we have 6 parts, and we divide the circle into 4 parts, like half of the first quadrant. Then of course this one will be 45 degrees. Right? Well, I shouldn't put 45 degrees there, so I should write this one should be pi over 4. Because the red part here, the red line here divide the upper part of the circle into 2 parts and the bottom into 2 parts. So I'll give you pi over 4. So one part here, 1, 2, 3, 4. Okay, and the angle over here will be pi over 6. Right? Because pi over 6 is 30 degrees. Pi over 4 is 45 degrees. So 45 degrees right here. So this is 45 degrees. Okay, and over here will be 30 degrees. There you go. I don't have enough space to write all the value over there. Usually, most of the instructor they printed out a unit circle. You just you just need to memorize it. You don't need to. Sometimes you need to understand it. And so the value over here will be pi over 3. And the angle, I'm sorry, the angle. And of course, over here will be pi over 2. Okay. Okay. So what do you think over here? At this point, what is the angle over here? Here, here, and here. So this is pi over 6, right? And this is pi over 2. From here to here is pi over 2, 90 degrees. Right here. 90 degrees, pi over 2. So pi over 2, we add one part because each part represents pi over 6. So pi over 2 add pi over 6 give you what?
120.
Pi over 2.
2 pi over 3.
Give you 2 pi over 3.
Yeah.
How about, this is pi over 4. So I divide into 4 parts, pi over 4. So pi over 2 added to pi over 4 give you 3 pi.
Thank you.
And you keep adding like that, then this one will be pi over 2 plus pi over 3. Pi over 2 plus 3 will be 7 pi over 2, right?
5 pi over 6.
Oh, pi over 6. Yeah. Pi over 6. Well, you know, pi over 2. No, you add this to this, so this is pi over 3 though. So this is 60 degrees from here to here. So pi over 2 plus pi over 3. Oh yes, 5 pi over 6. Okay. Yeah, we go 5 LCD here, you multiply by 3, 3, 2, 2. And over here would be pi. Okay. How about this one?
7 pi over 6.
Because pi plus pi over 6, 7 pi over 6. And over here will be pi plus pi over 4.
5 pi over 4.
And over here will be
4 pi over 3.
4 pi over 3. And over here will be pi plus pi over 2. Will be 3 pi over 2. Okay. So 3 pi over 2 plus pi over 6.
5 pi over 3.
5 pi over 3 too. Okay. And 3 pi over 2 plus pi over 4.
7 pi over 4.
7 pi over 4. Pi over 2, 3 pi over 2 plus pi over 6.
11 pi over 6.
Okay. And of course, I forgot to mention this. Let's go back to the circular function here. Because sine of s equal to y, and y is the vertical axis. So right now, actually, the y-axis become the sine axis. So I can write this as sine of s. Or maybe you can use sine of theta, because right now theta equals s. Okay. So In the unit circle, the y-axis is the sine axis. In the x-axis become the cosine axis. Okay. In some textbook, they write it as sine of theta. Okay. You can put that too, sine theta, because actually s equals theta. And because this is sine of theta, so the value, the y component of each point here, okay, it gives you the value of the sine of special angle. For example, here pi over 6. The x component is this is cosine. The x component. The x component will be the cosine. And cosine of pi over 6, you memorize the table. Cosine of pi over 6 give you what? Cosine of 6 is cosine of 30 degrees, right? And cosine of 30 degrees is, what is the value? What is cosine of 30 degrees?
3 squared over 2.
Square root of 3 over 2?
Yeah.
Okay.
Yes.
Is that correct?
Square root of 3.
Square root of 3 over 2. How about the y component? Y component become the sine because okay, become what?
1.
Here you go. So if you keep doing like that, you get all the coordinate for pi over 4, pi over 3, pi over 2, and so on. So I'm not gonna just go ahead and write all everything. Maybe I'm gonna do one more. How about I do pi over 3? So cosine, will be the x component, cosine of pi over 3, 60 degrees is half. Okay, and the sine of 60 degrees is square root of 3 over 2. How about this one, the quadrantal position? I already give you the coordinate already. So sine of pi over 2 will be 0. Remember last time I gave you the table? And it says sine of 90 degrees, 0. So it's corresponding to this. Sine of pi over 2 is 0. And cosine give you 1. Cosine of pi over 2 give you 1. Okay? And so on, you can memorize, you can get the rest of the unit circle. So there's two ways of memorize the value of special angle. You can use the table last time I provided, or you can derive the unit circle and memorize all the value at each point. In my opinion, I think the table is easier than the unit circle, because just think about it, you have to derive the whole circle. It will probably take a lot of time. So instead of memorize the unit circle and each point and each value on that, you memorize the table. That's much easier. But you have to understand that. You have to understand the unit circle, and you have to understand the sine. The sine axis is the y-axis, and the cosine axis will become the x-axis. Okay? Because later on, we're gonna use the unit circle to solve trigonometry equation. Okay? Any other question? Anyone who does not understand anything here? Should be very simple. Okay, and again, of course, will be the first quadrant, second quadrant, and this is third one. This is the fourth one. And of course, all four cases I provided you last time is also work for the unit circle. Okay, so if I consider 2 pi over 3 angle, so it will be from here over here, 2 pi over 3. Then of course, this will be the reference. Okay, it's the same thing. Any question? Okay, that's all for the short lecture today. So we're gonna practice on some problem. Oh, let's see, before we do problem, let me see. I just want to add 2 more information here. So you see sine, the y-axis become the sine, and they have the boundary in between 1 and -1. So I can say that the sine function, sine of theta, is always between 1 and -1. Okay, and the same thing for cosine, between 1 and -1. This information is very important too, okay? So I want you to memorize that. Okay, that's it. So let me see, I can put some example, some problem on the whiteboard. Let's do example related to the formula. Last time I provided you the formula, but we had not enough time to do the example. So let's do one of the example here. Okay. So that's how we learned about the arc length s equal to theta r, and I know that theta must be in radian, and the area is 1/2 r squared theta, and theta again must be in radian. So if it gives you the angle in degree, you have to change to gradient, okay, using proportion. Okay, so I have 2 circles like this. Okay, and these 2 circles are tangent to each other. Another center here. Okay. And I know the radius of this circle is 4. Then the radius of this circle here is 2. Okay. And I draw another tangent from this circle, so this will be the radius. So another tangent here. So I draw this one tangent, and because it's tangent, so it must be perpendicular to the radius. Okay, because of tangent. Okay, I don't know if you still remember that when you had geometry. Tangent always perpendicular to the radius. Well, it's not really perfect, so let me fix that. There you go. There you go. It's got it. Alright. And I want you to find the error here. Let's see. So this is 90, but it's kind of not really 90. So the way I draw is not really perfect, but I mean, just consider it's 90, okay? It's 90. Alright. So how are we going to find the area of that part? Think a little bit. What do you think? Let's take a few minutes to think about how we should approach this problem. Then I don't know if some of you can give me the idea how to do it, how to start. The bad thing is that sometimes, you know, I give you this, but I don't give you the angle here and here. But I think we can find an angle there. Yeah, it's not really scale. I mean, but that's okay.
Is that 4 and 2 supposed to be the radius number? What is that 2 and 4?
1, 2.
The in the circles, yeah, there's 4 and 2.
4, 2, 4 is 4 is the radius of this one.
Okay.
Yeah, so I'm gonna just write. So the big radius is 4.
Okay.
So this is the center O1, O2. Let me call this A and B. So let me call this the touching point right here is C. Okay. So O1C is 4, which is the big radius, and O2C is 2,
Okay.
which is the small radius. So I think this problem is very good because help you train the brain. So if you can do this one, you can do one of the problem in the assignment. Okay. First of all, you have to think that, okay, with the information they give you here,
Yeah.
any other information can we get out of this?
Is it a perfect rectangle or
What's that?
is that supposed to be a perfect rectangle or is it a normal or is it an
This one is should be the trapezoid.
Okay.
Because this is perpendicular here, this perpendicular here, so this and this should be parallel to it, and it look like parallel.
Okay.
Yeah. So this is trapezoid.
Okay.
Okay, this is a trapezoid.
I thought that was like this.
So could we use could we find angle just by using radius?
All right. Okay. So I have 2 marker, 3 marker here. So I'm going to divide this ball into 3 parts. Anyone can come here and finish this problem. I'll give you 5 points on the test.
Oh.
5 points on the test. Five points. Let's see. Well, first of all, you have to think, okay, with 4 and 2, what can we get out of 4 and 2? What can we get out of 4 and 2? Yeah, it's not really in scale because look at that. This is 4 and my 2 is kind of too big, right?
Yeah.
So kind of smaller. But just imagine. Just imagine this is smaller. It's not really double.
So that means
Go.
No, like that's like where you get 4 and 2 from.
That's okay. Go ahead. Go ahead. I mean, you can get them wrong. That's fine. But whatever you think, write it on the board. I really recommend. Yeah, but you have a question?
Well, you asked like what 4 and 2 tell us. What tells us the other?
Yeah,
lines.
1, 4, and 2. What can we get out of 4 and 2?
You can get the other line, the other leg of the trapezoid. So like we know the radius in the middle. So if one's 4, then the one going down should be 4. I'd assume.
Should be in this one?
Yeah, it should be 4.
All right. Oh, good.
And the other one
is
should-
4.
Should be
Yeah.
2.
It's 2.
Yeah.
Okay.
And then wouldn't AB total 6?
AB with 6?
Yeah.
No, because this is not rectangle. This is trapezoid. This is slanted. You see that? This is slanted. This is 4 and 6. 4 and 6 should be a lot bigger than A and B. Because it's trapezoid. Actually, when I redraw it, it should be, when I draw it in scale, it should be like that. Like that. This 4 here, 2 here, and this is 6 here.
Okay.
Yeah.
Now I get it.
So we're gonna crack this problem, and we're gonna have time. We're gonna crack a couple more. 5 points here, guys. Anyone? Think. What is your opinion in order to find a certain area? What should you do first? Let's do the brainstorm tree. Okay, let's do the brainstorm. This is our goal. Okay, the area. So in order to get that goal, what should we get?
Well, we need to get the sides, which we got. So,
What should we get? And then, if we keep moving, what should we get in order to get this goal? Well, probably 2 or 3, depends, okay? So, this is our goal. So, in order to get a goal, you need to get something, right? So, in order to get that something, you need to get something else. Maybe. And remember, we are learning this. So probably we don't need the first one, but we're looking for the area. Yeah, probably we have to use one of them also. So I don't know which one yet, but probably one of them. Must be. All right. Hell. The second problem, I want to write it out in case you keep thinking about that and have fun with that. The second problem is tangent. If I give you tangent theta equal to 3/5, and I want you to evaluate. Okay, A equal to sine theta plus cosine theta over sine theta minus cosine theta. Oh, alpha, I'm sorry. Oh, this alpha. Okay. So this 2 points. You guys come up here and do it. And I have the third one too. Even sine alpha equals 3/4. And I know alpha is between pi/2, alpha and pi. And I want you to calculate A2 tangent alpha minus 3 cotangent alpha over cosine alpha plus tangent alpha. And the last one is here. So with the first one, 5 points. The other ones, 2 points. Okay, evaluate M, 3 cosine alpha minus sine alpha over cosine alpha plus 3 sine. So we're going to use all the concept and whatever we learned so far to crack this problem. Okay, 2 points, 2 points, 2 points. just practicing time. We don't have anything, no new lecture except for the unit circle. Actually, the unit circle is actually what we already learned too. It's all special angle. Yeah.
What's that symbol?
Oh, it's an M.
Okay.
It's just M. I just call that expression M. So I call this A, and I call that A. You can call it anything you want. And again, I have to say that for all the problems I have on the whiteboard, you don't use anything other than what you already learned. You don't have to use anything like really advanced. No. Because we learn trigonometry, so of course we have to use trigonometry. Nothing new. Okay? Someone must be able to do the other problem anyway. I have 3 marks right here. I want to give points to you guys. How about let me do one of the problems. Okay, let me do the tangent 3/5, and maybe based on what I'm doing, you can do a sine. Alright. So they give you tangent of 3/5, and tangent is opposite over adjacent. So the 3 is this alpha here, right? Opposite over adjacent phi. So with Pythagorean theorem, the value over here, the hypotenuse will be square root of what?
34.
34. Can we find sine alpha? So sine will be opposite over no, hypotenuse. Alright. Can we find cosine alpha? So A will be 3 over square root of 34 plus 5 square root of 34 over 3 over square root of 34 minus 5 over square root of 34. And you have to simplify it. 5 common denominator. If you don't have to, then you get that. Everyone's clear. Then can you apply the same strategy to do A and M here? Anyone? So let's try to get in group, okay? trying to get them good to see how you guys help each other. So let me put you guys in a group of 3, okay, or 4. Let's turn around. Let's turn around and talk to each other how to get the problem sine alpha equals 3 over 4 and tangent of alpha. Go ahead, turn around and talk to each other. Come on, come on. Over here too.
Equals negative
Turn
4.
around, turn around. Yep, get together, yep. Turn around, and let's do a group of 4 here. Okay. Alright, let's discuss and talk. I'm gonna keep adding more problems here for you. And again, for any problem, it will be 2 points, okay? And I want you guys to come up with the answer right on the whiteboard, okay? Okay, I'm gonna have another one.
Yeah, it's giving us the opposite of the hypotenuse, and we see that
I'm doing
the last side.
So it's 5, right?
16 minus 9.
That's right.
Because it's going to be c squared minus, let's say a squared.
Correct.
Because the hypotenuse
Yeah.
is c.
5 over 2 is 90.
That's what I like. I want to hear more noise, more noise.
The last side.
So it's in between.
Quadrant 2.
It's greater than 90 but less than 180. So yeah, quadrant 2.
That's just angle
And we need to find
130. That's angle 135.
We need to find 2.
Times
So
2,
10.
right?
Yeah. It's actually c.
Alright, one more problem.
Cosine of.
This problem, 5 points.
So then this is going to be square root of 7 over 3.
Actually, based on the one I just finished, you can do an A and M there. Apply the same strategy. You should get the answer. But this one 5 points. I probably give you 10 points if you guys figure it out. We still have a lot of time. Come on, give me more noise, more discuss. Alright, anyone volunteer to get 2 points? I want to add more points here, guys.
I just
And
want
what?
to get Is it the angle you want?
Well, I mean, yeah, but I'm not using it. I'll be able to do this other one.
More talking, guys, more talking, more discussing. Come on. We learn from each other. You guys learn from me, and you guys learn from each other.
I think we're gonna go get okay. It's complicated.
Probably at the end, we can just take it into account. If you want to get like an exact number. Do that
I might put one of the 2-point problem on the test, similar to that on the test. So again, you just do the same way I just did here. You draw the triangle, and when you draw the triangle, you calculate each trigonometry ratio. Don't ever convert into decimal. If you have fraction, for example, in this case I have sine alpha 3 over square root of 34. You just keep it 3 over square root of 34. Don't ever convert it to decimal, okay?
Are we allowed to round the decimal?
No, don't round.
No round.
Just leave it fraction. Just leave it fraction. Of course, for the last one, for the final answer, you have to simplify this, of course. Yeah. But don't convert 3 over square root 34 to decimal.
I've got an answer, but I don't know how to simplify it.
Come up. Alright, just come up here. Come up here. Alright, so we got 2 points, guys. Come on, guys. So you're gonna get 2 points from you.
Thank you.
Okay, come on.
Sorry.
Well, even you get like 90%, I can give you like 1 point. Alright, you can pick any problem you want to do.
Here for this one.
Okay.
So, sine theta is 3 over 4. That means our
Don't mix my equal sign, Rachel. Sine and alpha equal. Yeah. Okay.
thank you. Y equals 3 and R equals 4.
Do you want to, yeah, go ahead and draw the triangle so that, yes. Go ahead and draw the triangle so that our student can see. Okay. And make sure you level what angle you're talking about.
Okay.
So all you have to remember to know is the sine equal to opposite over hypotenuse. Sine equal to opposite cosine adjacent over hypotenuse.
I don't have an angle, I just worked with the numbers I had.
Well, you can draw the angle as I do here. You see that?
Okay,
The triangle here, you see sine, yeah, okay.
okay.
So you can draw the triangle like that.
Okay.
You want to go that way around? Okay, that's fine.
That's
It
okay?
doesn't matter.
Okay.
It doesn't matter.
Okay.
And it depends on what. It doesn't matter which angle you want to pick. It must be the smaller one. Okay. So where's the angle? Okay. So that is the angle you want to pick. Okay. So that is see a sine equal to opposite. So it's opposite of that angle will be what? Yes, that one. Okay. If you pick that one as the angle.
Gotcha.
Okay.
Okay.
Usually, they draw like this. But I mean, you
Okay.
can draw like that too.
This one
Okay.
had negative.
Thank you.
I'm wondering, like,
Come on, guys. I need more students here on the whiteboard
that's what I need.
to do this.
Because you have to.
2 points. 2 points. 2 points is a lot of this test, guys. Think about it. Give you guys more chance, more opportunity. And find it probably before the test, you probably have 10 points.
Nick, every time you just cross this out with that, and then that with that.
Okay.
You don't even have those study quarters.
Yeah, you do.
Oh, wait. I just have 8 divided by 34.
Isn't it to get rid of?
I know, but if you don't, it just makes it easier.
All right. Richard, can you explain to the class about how you get whatever you have on the whiteboard so far? Everybody turn around and pay attention to this. Okay.
So the tangent, I'm still working on remembering that.
That's okay.
The opposite over
Okay,
adjacent
so
and
what's the
tangent.
opposite?
So what I remember for now is
Okay.
tangent is y over x. So I have my y, my x is square root of 7.
So when you're gonna label x on the,
Thank you.
here you go. That's why you see that usually the x must be the horizontal.
Yeah.
So it's good if you draw the triangle like this instead
And
of like that.
Yeah,
You know?
I can see that.
You know?
Yeah.
I can say y is the hypotenuse.
Then let me
And y is the opposite.
I'll change it to
Yes. There you go.
Okay.
So the angle must be over there. That's easier.
Okay, gotcha. And then my other one was 3? 3. Yes.
Okay. So that should be the alpha. Put alpha. Here you go.
Okay.
All right. So go ahead and expand. Yeah.
Tangent is y over x, so that's easy enough. It's 3 over square root of 7. Cotangent is x over r, so square root of 7 over, no, cotangent, I'm sorry, x over y.
Mm-hmm.
Square root of 7 over
So
3.
so it'll be
And then cosine is x over r, and tangent is y over x.
Okay. So everybody got it? So she used x and y. So you can use opposite of adjacent, something like that.
Yeah,
Because that's what she yes.
Would x not be negative square root of 7 because it is in the
Exactly,
second
man.
Okay.
Haha. So you have to put this into consideration. Right now, the alpha, what quadrant is this?
Second quadrant.
Second quadrant. If it's second quadrant, the x is positive or negative.
Yeah, it's negative.
Because you remember when you take square root, give you plus and minus. So you have, yes.
You have to pick the right
You
one.
have to pick the right one, so make it go to negative. So you have to change that. There you go. Everybody agree with that?
Yes. Okay.
All right, now it's your job is to simplify that.
Oh God.
That's the fun part. Okay.
Well, you must be able to simplify this, okay?
How do you remove the square root from the denominator?
I mean, probably you just need to combine so that it look better. You know, that's all. You know, because right now I see that 7 over 4.
The square root is 34.
Well, let me see. Hold on, be careful. So, if it is second quadrant,
You didn't have one. You didn't have
and over here is tangent, right? Tangent of the second quadrant is positive or negative. Okay, so she's got it correct. Cotangent is positive or negative?
like it starts
Negative.
off
How about
That's 3.
cosine?
square root of 34 and 5 over square
Negative.
root of 34.
Okay, so all negative. Okay, I just want to check.
I understand.
Okay, good. Right now everything is negative.
Yeah, alright, I understand.
Okay. We see we can simplify it to make it better, okay? To beautify it, to see if we can or not. Probably not,
Not much.
okay? Not much. Because you see that at the bottom we have square root 7, 3, and the bottom, the other one is square root 7 and 4. So the common denominator, if you do it, you can simplify just a little bit, not much. Oh, I'm still waiting on someone over here, guys. I need someone over here. I need someone over there.
Try.
You can try. Very good. Well, let's you guys try. Come on, be brave. Where's all the guy? Come on, where's all the guy?
This is not working.
Another one?
I kind of like. Sorry. Yeah.
What? It's just not
Oh,
bad.
okay, I don't know.
You draw it like
Okay.
you just hold it like upward maybe. Oh, okay, let me
I
see.
didn't see another option, but I think it's probably there.
Okay. Anyone? Any idea? Okay, how do you go from here to here? Can you explain it to me?
I just got the radicals out of the denominator was all.
Okay, so she rationalized it. Okay.
And that was really all I did there.
Then you simplify this.
Mm-hmm.
Can you simplify this, guy? This and this.
I can't see.
Oh,
Sorry.
this and this. What are you asking? She crossed them out.
At least one of them would cancel out. No?
Remember, in order to cancel, everything must be in product form. Right now you have addition and subtraction.
There's no multiplication.
Yeah.
They're multiplied, yes.
Yeah.
But not because.
Okay, so look like that way of simplifying is not good. Okay.
So then,
Come on, I need a brave guy over here. I need someone to be. I need someone to be there. Or at least someone to be here. So I give you sine of alpha equal to square root of 6 over 3. Evaluate p, tangent square alpha plus cotangent square alpha over sine square alpha cosine square alpha. This is harder than that because 5 point, 2 point. Anyone, I need a guy. I need a guy. Come on, come on, come on. Alright. Keep going. It looks pretty good to me. Alright.
I was just
The
confused.
strategy is good. She draw the triangle. So that's a good strategy.
I was just confused about this minus because I didn't want to like put like negative value for a value of you see what I'm saying?
So right now tangent is negative, right?
Correct. It's just
So if tangent is negative, what is the possible? What would be the quadrant?
four, negative.
Be 2 or 4.
2 and 4. Okay. So if 2 and 4, the cosine will be positive. Yeah. So I think I'm gonna just add a little bit more information here. So it's just use quadrant 2. Use quadrant 2. Yes. All right. So from there, yeah. So I missed some information. So it's easier for you to do. Okay. So right now.
This will just stay like that then.
Okay. So cosine quadrant 2 is positive. And sine will be.
Negative.
Ah.
okay. So
Sine
this
will be
will be
negative.
here.
Yeah.
Okay.
Mhm. Okay. Let's see this one over here. Come on, someone can help you. Can help her how to simplify this. Okay. That look pretty clean to me. Yeah, right there because she canceled number 3, right? Then she has the same common denominator 7. All right. All right. Look at this. Look at this. Oh, okay. Keep going. Almost. Wonderful. All right, everybody. Equal to ratio 2. Rachel. Can you stop a minute? Everybody, turn around. Can you explain the whole problem to the rest of the class? How you get it?
Well, starting with what is given,
Okay.
we draw a triangle,
Okay.
and tangent is opposite over adjacent. And this is the angle, then this is the opposite, and adjacent is 3. And by using the theorem, we can get the value for hypotenuse. And considering this,
Quadrant 2.
yeah, we have to make sure that we keep cosine negative, right? Yeah. No. Correct. This is
quadrant
Yeah,
2 sine is,
Sine is negative.
is that quadrant 2 sine is negative?
Positive.
Positive. So this is to be plus,
Oh,
right?
So I had it right.
You got it right before?
I got it right.
Oh, so you got it. Quadrant 2.
Okay, no worries. So it just.
But okay, keep going with the strategy. Keep going with the strategy. You just mess up with the sign. Okay, keep
Correct.
going. Oh, yes.
So
Keep going.
you just plug in the cosine is adjacent over hypotenuse. Just plug everything in this. So sine is opposite over hypotenuse. So you just plug it in, and
Okay.
the rest is like algebraic. I got messed up.
Okay. Can you explain the algebra to those who okay, for example, like 9 over square root 11 minus, should be minus over there, right? 9 over square root of 11,
For P, what is
because it's minus, so
Okay,
it's
correct.
minus. Here,
I can't read it.
3.
No, I get it. Sine squared alpha.
cosine square.
Oh,
Cosine
Sine square and 5 times cosine square.
Well, this
I'm
is
talking
just
about multiplying.
multiplication.
That's multiplication, so
Yeah.
negative time,
Yeah.
okay.
And
So
then
this will be minus.
Correct.
There you go.
And then this is the same concept. Minus
Uh-huh.
2 times 3 is minus 6 over square root 11.
Everybody got what
So
Jana?
Yeah, because it's the same square root, we can put it up here and have it like kind of
Okay.
simplified. And then this is equal to 9 minus 2 times,
So let's use
okay, that's how I got that. And this is minus that.
all right. Okay. Everybody, any question for her? So all you have to do is you draw the triangle. Then you memorize sides opposite over hypotenuse, something like that. Cosine adjacent hypotenuse. Rachel used y over r. Same thing over here. Same thing here. Sine, cosine, x over r. Same thing. R is actually the hypotenuse. Yeah. Okay. So it's good. She just messed up with a little bit. She doesn't know how to get the sign, but right now, alright, she got 1 point at least. Come on.
Okay, thank you.
I'm looking for someone over here. We have 5 minutes left, guy. Come on. Where's all the guys? Okay, Rachel been doing pretty well. Okay, keep going. Oh, keep going. So right now you have the same denominator. So you just combine it, right? Over 7. Very good.
Actually, I was giving myself. enough
Let's just
space.
write over here.
Yeah.
Just write over here. Just stand
Sometime
up.
next week. Like a Monday or Wednesday.
What day is the exam on?
We have about 10 days. I believe it's February.
When is it Wednesday?
Yes, it is. It's
Is
February.
it here or in the center?
Yes, it's Wednesday. February 5th. Very
Is it
soon,
in this
yeah.
room? In
This room, yeah. Over here, Wednesday. So maybe next week. It's next week already, guys. Wednesday next week. And Monday we're gonna cover some one more concept, and that's it. On the test. All right, very good. Well, keep going.
Doesn't that equal 1?
Oh, come on. All right, okay. Square root of 7 over 7. So square root of 7 over 7 divided by square root of 7 give you guys. Give you what?
Isn't it?
1?
1,
Oh, what's that 1?
isn't it?
No.
Because if you have square root of 7 over
7.
times the square root of 7
It's
over
1.
1.
No, it's time 1 over square root because it's the square root of 7 over 1. You see what I
Well,
so
yeah,
you keep
but
changing
if
flip.
you do like times the square root of 7 over the square root of 7,
Because it's just like, you know.
then this side is times the square root of 7, right?
And
This is
this
times
is this is gets you married, right?
Yeah.
So you have square root of 7 over
over
7.
7. Okay,
So
no, I get you,
yeah.
I get you, okay.
But that's what I'm
I was,
I'm about to go to
that
kindergarten.
part's 1 and this part's 7. Okay, gotcha. That part's
So 1 over square root of 7.
plus 1.
Yeah. 1 over 7. Alright, can you explain really quick the algebra over there? Everybody turn around. We have, just bear with me for a couple more minutes. You explain and we finish.
So, once you're here, then to put a common denominator and just multiply out. That's easy enough. So common denominator 7, common denominator here I chose 28. And combine them so you have just the two fractions. And here you just end up with the square root of 7 in the denominator. Multiply that times the square root of 7 over the square root of 7. And that.
That's it, right?
Yeah, that's it.
Alright, she gonna get at least 1 point. We're gonna get 1 point. That's all for today, guys. Come on. I need more guys coming up. Last time we have 2 girls ready. Now today we have 2 girls. Where's all the guys? Where's all my guys?
So what was the approach in this?
That's approaches? Okay.
Yes.
If I have time, I'm gonna go through this. The approaches, you gotta find the area of this 2 piece, find the area of the trapezoid. Subtract this 2 piece using this one. The area of this using this formula. But you need to find the theta. That will be the hard part. Because in order to find the area of the sector, you need to know theta. So you need to find theta first. Then you find the area of the trapezoid.
How you find theta? Can you explain that first?
How you find theta?
Yeah.
Think about that. Come on, this is fine.
Think about it.
Keep going, keep thinking.
Okay.
Keep thinking.
Cosecant, right?
Cosecant?
Well, like if you have adjacent over, like use triangle.
You can use that if you want
Can
to.
you just email the answer?
But you need to find the theta. You need to find
Where
theta.
can I find theta?
Yeah, 11.25.
Oh, the 45. I did not.
What'd you get?
I got 1.25.
How'd you get 1.25?
Well, if you
1.2 something. I got
okay,
like
if you have
87
4
over
and
90.
4, right?
1, 4.
See, I just made the
So-
triangle.
Well, I mean, you can look at it. This is not really skilled. How about you look at this one?
Yeah.
Look at that one, it's easier, right? So you need to find an angle here to find. You need to find an angle here
Squared.
and you need to
plus
find an
b
angle
squared
here
equal to 3 squared.
to
So that
get
becomes 6 plus b squared.
the area of the sector.
Well, that makes sense. What
Then
what
b
would
equals
you use to
3.
find that
The
angle?
area of it. What do you use to find this?
Uh-huh.
Would you use reference angle?
Another,
Can you
Yeah, that's
another
right. I think.
triangle inside.
Another one?
Is it what? Is it
Oh, she got
like
you.
here?
Yeah,
Oh,
And then-
she almost there, guys. She almost there.
okay.
So
Okay,
this is then
so-
another right triangle.
Another right triangle there.
Okay, so then you have the
I have
hypotenuse.
the-
my favorite.
And
You
then-
had
I
anybody?
didn't want to go off the board.
Oh, you
Come on, I
should
told
do
you
it.
to be brave. Come up
So
and
this
see.
is
Yeah,
6 and this is
exactly. There you go. She got it there. She got it
Okay.
there.
But how do you get that the bottom one's 6?
Because
Because
they are
the-
parallel
yeah.
and equal.
So then it turns to a rectangle. When you put that
Yeah,
line above
this-
it, it'd be
Oh,
rectangle,
yeah,
so
yeah, yeah.
Give me 6 and
Okay.
6.
All right.
Okay.
Yeah, yeah. That's the strategy. That is the strategy. If we have time, the next time I'm gonna let work on the wife to finish that, and we have time. We're gonna finish this too. Okay.
Time to weekend.
Good.